about the Y for each of these is essentially like part A or part B of 61, whichever one I didn't do. So when I replicate, that was like me taking my rabbit and me taking my friend's rabbit, and that was it. Well, I don't know if my rabbit started out the same as their rabbit, so that wasn't very helpful. So in replication, if I take a bunch of things, are they going to all be the exact same? No. So the variation that's going to occur, we want that to just be by chance. But it's something like if you get a whole bunch of them, you're going to have a couple that are smaller and a couple that are bigger, but a lot of them that are kind of in the middle kind of thing. That's your idea of why we do the replication. So variation between treatments can be distinguished from just chance variation. So if I were dealing with heights of students and I only pick 3 and I happen to get somebody that's really short, they're going to have a really big impact. So that group, were they affected because we just had one really short person, or are they affected because of whatever treatment I gave them? So randomization. Okay, so let's go a different aspect here. I say the biology experiment. Kind of think of biology. Back when they don't let y'all dissect anything right here anymore, do you? In biology, y'all don't actually take any animals and do anything with them. They do. What do y'all do?
Well, we're going to do
pigs. Do you get an option? So that's a good idea of what to deal with. So this is like an idea of, let's say you have to dissect a frog. And you get the option of dissecting the frog actually or doing one electronically. What's going to happen if I give you that option? Think about getting into groups. Getting into those groups, you making that choice. What issues am I going to have there? I'm being very vague. I want y'all to think about this. So I say, hey, you can either dissect this frog or you can do it on the internet. What? The groups will be different size. What else? What about the people that choose each group? They probably have similar views. If I let you pick, people who are of the same group or whatever are probably going to go together. So like maybe the smart people could choose either one here technically, but maybe they're like, I don't want to waste my time with the ins and outs. I can do it electronically and do it better and get it faster. Maybe the smart people end up going to that route. Or maybe the people that aren't very smart are thinking there's too much to deal with inside. I'm just going to do it electronically and it'll be easier. But there can be an issue that travels through by letting you pick, right? So the randomization takes that out of it. So randomization attempts to eliminate bias by hopefully creating roughly equivalent groups. Now, does that mean every single time they're going to be exactly perfect? No. But it is leaving it to chance as opposed to letting people pick it for a certain reason. And then we've talked about control here. We've talked about control in 2 different aspects. One aspect of control is just actually controlling for variables, like controlling like the temperature and stuff like that. If it is that, we are trying to eliminate, and I know I haven't written this down yet, but I think y'all can be fine with it. Eliminate lurking variables. If we're in whatever home economic class and they're baking cakes, and one class is in the morning and one class is in the afternoon, well, those ovens have been used all day, and maybe they don't work as well in the afternoon, or they're so hot that it changes things a lot. So we want to eliminate that kind of lurking variable that we can deal with. The other aspect of control is a what? And if we're talking about a control group, what's the purpose of a control group? The baseline to compare to. Now, as far as the control, are we ever going to eliminate every single lurking variable? No, but we want to deal with as much as possible. That's why that one problem was so descriptive. It had like a sentence or two about all the things they were trying to control for that one scenario with the preschoolers. I don't really want to go into this, but I want to write while we're writing. Go ahead and write that. All right, so I'm going to talk about a couple things and then write. Let's say we are offering we're trying out a new workout program. And it's this new high intensity workout problem that's supposed to be really, really, really good. But we need people to volunteer to try it so that we have data to use. You with me on that? Then I get my results back and it worked. So we've got to talk about two pieces along the way there. How did I get my people? I asked people to volunteer. What kind of people are going to volunteer? People who probably want to work out. If I do some high intensity workout program, am I going to get somebody off the couch who's never tried to work out before? So do I know if I'm trying to promote my workout plan, I need to know that it works for who? For everybody. But I'm not going to have that information if I have volunteers, because I'm only going to be able to say it does or doesn't work for who? People that are like people who want to volunteer to do that, right? So there's a big issue with volunteers. Now, this we end up spending like the second half of class on, or second half of the semester on, but we need to mention it now. Let's say, don't write any of this. Their scores increased. Well, no, I'll do BMI. So did it work or did it not? So why don't you know that? All right, so that's your first thing, which is what I wanted you to get out of that. Okay, so was it successful or was it not? What? So what if I say, on average, that's 72 pounds? Is it successful? Would y'all feel okay to say yes there, but no, maybe not to 2 now? So when does it switch that line to saying yes to no? And that's where we essentially spend the second half of our entire class. But if they lose an average of 72 pounds, was it a fluke? Probably not. If they lost an average of 2 pounds, could it have been a fluke? Yes. So for right now, what I need you to understand about that is it is so unlikely to have just happened by chance that it probably related. So statistically significant, as far as your definition of what you need to know today, is results showed such extremes that it is unlikely to just be variation by chance. Like I said, we will expand on that a lot. But for right now, you need to know that result is so extreme that it's unlikely that that just happened by chance. Somebody goes out fishing on a lake and they catch the biggest fish that's ever been caught on that lake. That happens, right? They turn around and do it again the second day. Now we start to go, okay, maybe they're doing something. Maybe it wasn't just that they got lucky that day. That's what I need you to know about statistically significant for now. It's so unlikely to have just happened by chance that maybe there's a reason for it. And then the other thing we talked about, consequences of using volunteers. What can we not do with the results? Can't apply or generalize the results to the entire population. And generalize, I'm going to also write a definition for that because it seems silly. We use this term a lot in our class. So if I say the results of my new high intense workout plan are statistically significant based off of my study with my volunteers, we just said, what can I not do with that conclusion of saying it is statistically significant? I cannot apply it to a bigger group. So the bigger group to which you can apply that conclusion is who you generalize to. So generalizability is the population to which your results apply. So if I ask for volunteers, I can only apply my results to volunteers. So if we want to generalize it to the entire population, you have to randomly select from that entire population. So this and the last slide that I typed are four really, really, really key things that tie in a lot of what we've been saying. I kind of want to split the video here. Yeah. I don't care. If you clean up.